We know, like, okay, this is shortening of the biceps at the shoulder. This is lengthening at the shoulder, right? And you know, with the triceps specific to the long head, etc. So when we look at making those positions a little bit more optimal or a little bit more individualized, in terms of the different heads of the biceps and whatnot. So let's start with the triceps, because that one's the kind of the most obvious. So we look at like these muscles and we're like, well, are they shoulder extensors? Are they shoulder flexors? And we have to look at, well, in order for a bicep or tricep to have the function of a shoulder flexor or extensor, there's a lot of conditions that would have to occur, right? Because so when we have two joint muscles in a body, right, they can never be applying force at just one joint, right? Is there any way that a bicep could be causing shoulder flexion and not simultaneously causing elbow flexion, or at least not have force at both of those, right?
Yeah.
So when we look at setting that up, one of the good things is that when you got into those positions, you were keeping a fixed shoulder position and then performing the, you know, the flexion or extension respectively, which is going to be ideal. The next thing that we have to look at then is like, well, if there was going to be an ability for this two joint muscle to only move one joint, that would mean that either the resistance or antagonistic tissues would have to be fixating the other joint. So that means if I'm going to do a bicep curl out here and it were not going to be translated into a shorter bicep position by the bicep tension, that means the antagonistic tissue has to be fixing the shoulder and providing resistance to this motion so that more of that force translates into this motion.
Yeah.
Okay. So when we're looking at that, our whole goal in terms of setting up a position or a movement is trying to like allow for that in the most efficient way possible. So like if I want to make sure that my bicep is contributing to as much elbow flexion as possible, I need to make sure that that managing of the shoulder joint is as easy as possible, and then the reverse for the triceps. And the same thing goes for hamstrings and all of these other things, right? So the more complicated it is to manage either of those joints, the less these two joint muscles can really contribute, and the more they become kind of just like stabilizers of the joint. So, and then the other thing is that when we look at a two joint muscle, a lot of times if it's the shoulder or the hip, it's going to have like kind of multiple quote unquote functions at that joint, because it may not just be a flexor, it may have a degree of rotation, abduction, AD, or whatever, depending on the position that it's coming from.
Yeah.
So if we take that long head of triceps and we think of like, okay, if I'm trying to shorten the long head of triceps, is it actually an extension of the elbow, or should I actually be focusing on how do I actually make sure that long head of tricep is just actually in the plane of the scapula in a way where it wouldn't exhibit any other forces on the humerus. So in your pull-up video, you mentioned the scapular plane. And that's actually why I reached out, because it's like, okay, he understands the scapular plane. But then when we got to the triceps thing, we're extending essentially past the point where that long head would be approximating towards the scapular plane. So if we look at, you know, your anatomy here, right? We got a scapula and a humerus or whatever here, right? So as I'm going through extension, if this is supposed to be approximating basically my, you know, the long head of my tricep coming into here, right? Yeah. As I start to extend, so if the scapula is sitting on me here, right, and technically if it's on my back, right, it's going to be slightly like this, right, that angled scapular plane, right? If I overextend, I actually am starting to lengthen that long head of the tricep, right? So there's going to be a position essentially where your long head of the tricep is essentially doing nothing but actually tractioning the joint, meaning it's not going to add extension, rotation, anything. And from that point, what the long head of the tricep is then able to do is it's able to recycle all of the tension that it's putting into elbow extension into stability for the shoulder. And that's where you're going to get the maximal recruitment. But if I overextend, what's going to happen is if I would actually contract that long head of the tricep more, it would actually have to bring the arm forward, and there would be a degree of rotation depending on where you're coming from. So when we set people up for long head of the tricep, right, it's usually actually a little bit of abduction. It's kind of like in the plane of a rear delt motion. When you look at, I want the scapula to be in a position where at that point in time, you have to think about the rotational effect on the scapula that the long head's going to have too, and you want that to be lined up with all of the tissues, like the rhomboids and everything. So it's like at that point in time, if I were to tug on that long head of the triceps as hard as possible, it wouldn't do anything. Like everything would just essentially be sitting there and cinched. And that means from a stabilization point, everything's going to be good. So it's not going to be fully extended. It's going to be kind of here and slightly abducted in the scapular plane. If we're looking at, okay, how do I get the long head of the tricep so that if I actually squeeze the long head of my tricep here, it doesn't, like, it fixes my shoulder joint. It doesn't want to go forward or back, right? And what that ends up also being then the reciprocal lengthened position of the long head of the biceps, right? Yeah. So long head of triceps, long head of biceps are antagonistic, right? So in both of those, the position is not like down here. So if we think of long head of the biceps and stuff as well, right? It actually, in order to not have like a rotational force, is going to need to be stretched and a degree of AB. So it's actually kind of this position. It's not here, right? Or way back here. It's going to be this. So when we're looking at like functional anatomy on these two joint muscles, it's like, if I want to isolate the movement at one of those joints, I want to set up the other joint so that basically the only force coming from this two joint muscle is to traction the joint. And it's my opinion that when we look at like biceps and triceps and stuff like that, a lot of times in anatomy and kinesis or whatever, we're taught to like, well, okay, the rotator cuff is the thing that holds the shoulder together, which is stupid, right? It's like a used condom on the end of a fucking ball.
Everything
right?
Around the girl.
Yeah, it doesn't have the tissue strength or the mechanical strength to be able to technically do that. But if you look at how the body uses tension through the arm to traction the shoulder joint with those two joint muscles, so the bicep and the triceps, you have these big muscles that by the time we get to this joint, they are so much more efficient at actually pulling this in here than any of the rotator cuff muscles. And all of the rotator cuff muscles, in order to traction this, would have to like move it around and wobble it all over. Whereas the biceps and triceps, provided I'm not doing something like, some sort of jackassery, they're always going to be pulling this towards the glenoid, right? Yeah. So if we want to get the most out of these elbow flexion, elbow extension movements, especially in the two joint muscles, we want to make sure that we're positioning those two joint muscles in a place where they're going to have like a traction component at the shoulder joint. Specificity there, excuse me, specificity there is huge, right? So does that kind of make sense on the long head of the tricep and positioning that and not excessive extension, but in the scapular plane?
Yeah, for sure. It's interesting too, because if you just look at textbook definitions, kind of trying to make this conversation full circle and like connect the dots, or if this does get put out to help people connect the dots, just because it's considered a shoulder extender doesn't mean you need to maximize shoulder extension yet. The long head fully shortened. I totally hear what you're saying. And I think something that is an issue with the fitness space as a whole is that we're no longer feeling our bodies. We're no longer being in tune. We've lost the artistic side of bodybuilding. Like I would watch some old school bodybuilders execute a movement in a very interesting way that might be considered like incorrect form, but they might be doing something there intentionally because they feel a deeper stretch or a better contraction within some portion of the range. And like when I was just going through this elbow extension and messing around with, okay, where does my humerus actually have to be? How far back into extension do I have to get to feel the deepest amount of contraction? What point is that at? And does it actually change if I continue to extend? And it's not. So I'm able to take what you're saying and not just have it make sense because of the theory and because of the logic, but like feel it, just like actually do it, and then start connecting the dots that way. So how do you perform your kickbacks or your tricep extension exercises for the shortened portion of the range? Like what's your go-tos there?
Yeah, so I mean, our go-to is like well, in a gym setting is going to be like a cable crossover because for most people there's a certain degree of abduction they're going to need to be completely lined up, right? And so it's basically finding that spot. And for some people, it's actually easier for them to kind of like lock the tricep and then kind of find what there'll be. Like it doesn't have to be 100% contraction, but if it's like if you squeeze that and then you go into it, you find these kind of like soft end ranges where it's like if I'm not trying to aggressively do this and I'm just trying to find I find that there's kind of a stop there, like just a casual. If I'm just tensing my tricep, I just find that there's a casual spot where it's like it kind of wants to just like it's
Sure.
like there's a speed bump there. It's like I could drive past it, but
Yeah,
there's
yeah,
like that speed bump there. So in a lot of these positions, there's we're able to find and if in like in more detailed muscle testing, a lot of people are looking for soft end ranges for tissue specificity because of like, oh, right there, that's like I could this joint goes past that, but this tissue right here, that's where its role kind of ends, and now we
sure.
would be moving on to other structures and other tissues. So that's kind of what we do is we have people kind of find that spot, and then that's going to be where they're going to set up with a cable that's essentially going, in the same angle as the arm, but then up to whatever degree. And if we're trying to, from a resistance like curve profile perspective, if we're trying to make the short harder, we'll have them walk further away so the cable is pulling more that way,
Sure.
or if they want to load more the mid-range. But it's like you can have a mid-range resistance profile but work a muscle in its short position.
Sure. Sure.
So we teach like understanding the effect of training a muscle at a certain length versus applying a resistance profile to that length,
Yeah,
whether
yeah,
they're compounding, whether they're inverse, et cetera, et cetera. um, so that's, I mean, that's our main go-to. And then
yeah.
when it comes to the elbow flexion on the other side, right? So we have our, this is essentially the same thing for length and long headed biceps,
Sure.
right? For there's pretty much a pure antagonistic relationship at every joint position, and then so then the short, or I should length and tricep, right, is still going to be in scapular plane. So if we think of like, well, if I brought the arm around here, okay, and I would think about, okay, if I were to put tension in the long head of that tricep. So my scapula, it comes around, but it doesn't like it doesn't come all the way around, right? So if we were to put tension in the long head of my tricep in this position, two things are going to happen. One is it's going to want to like quote unquote abduct the arm to get
Sure.
back in line with that scapular plane. And the other thing is as it does that, there's going to be a small rotational component as it gets there, which is why when you see people like in here, they tend to want to go like this.
Yeah.
And you'll see a lot of people be like, well, no, like that's not lined up with the elbow. You should be like in here, and they'll
Yeah.
like twist them and be like, you got to do it this way. And in
Yeah.
reality, it's like, well, their long-headed tricep is trying like that. If they're putting tension in the long head of the tricep, that has to happen. And so the only way for them to stay here is to actually not contract the long head of the tricep and just rely on the other two heads,
Sure.
right? So for a lengthened position, it's going to be in that scapular plane, and it'll be here. And you can do the same thing. So if you kind of like come to terminal elbow flexion, and then you get in the scapular plane, you'll find like a soft end range, right? You'll get there, and it's like okay, I feel a stretch, and it's a soft end range, and everything else is like that's just going to be like just shoulder movement, from there. But that's it, right? So a lot of people will train this like way back here, and in
Sure.
reality, for most people, it's not very far to stretch that.
Sure. So you're saying if I go into more shoulder flexion here, even if I stay abducted, I'm not going to lengthen the long head of the tricep much more, maybe slightly more, but it's primarily going to come from the lats or something like that.
Yeah, it's a lot of that motion is just coming from the upward rotation of the scapula at that point in time and the
Sure.
elevation of the whole shoulder socket there, right? So, when we're looking at force output, if I put myself here and then all of a sudden I'm also loading another motion, in this case, that scapular rotation, that means that as I'm going through this, I've now made that position more neurologically complex
Sure.
than needed. And I'm putting other things in place that could be either a metabolic, neurological, or mechanical limitation,
Sure.
right? So it's better to be in that, well, this is pretty much, that's as stretch as it needs to get. And then I can go there and I'm not taxing any other motions or functions of the shoulder joint.
Yeah. So yeah, I hear what you're saying, man. Like for me, this would be my soft end range.
Mm-hmm.
I
Yep.
can get further than this, but that's because I'm actively contracting other muscles to put me here.
Yeah. Right. Yep. So, and then that would be the short position for the long head of the bicep as well.
Sure, sure.
Right.
So one thing that I guess I disagree with the commonly accepted belief of training the long head of the tricep is I actually feel like exercises in this lengthened position that are commonly like touted as like, okay, perform your overhead tricep extensions for the long head. The way I perceive that is those exercises can create more muscle damage in that target tissue because it's in a lengthened position.
Mm-hmm.
But I also believe when you're actually performing that concentric, because of the force length relationship, the medial head and the lateral head are most likely doing more of the concentric work. And then as you're performing your eccentric, that long head might be kind of, it is under a deeper stretch for sure. So it's receiving more of a mechanical stimulus in that sense. But from a concentric standpoint, what do you think's actually going on?
Well, first off, don't be muscleist. All right, let's treat all muscles equal. So,
Yeah.
if we look at the medial and the lateral heads, right, what is their fully lengthened position?
They're fully lengthened position.
Yeah,
Yeah, just elbow
it's
flex.
just elbow flexion, right? So if we put all three in an equally lengthened position, right, we can't be like, well, that's good for some and not for another. Does that make sense? Right? Because technically every tricep exercise we're doing is taking the medial and the long head or in the lateral head to a full stretch if we're going to full elbow flexion, right?
Sure.
So I mean, one, the lengthened position leading to more mechanical trauma is absolutely true.
Sure.
Okay. But what you have to understand is like, well, one, if I haven't lined up the long head of the tricep properly, then the medial and lateral head are always doing more work and it's doing less.
Sure.
Right? So basically, every improper setup, every overextended, every wrapped around rotation thing or whatever is very little long head. So you'll also get a little bit of a bias in terms of like when you're evaluating how people have experienced these movements because the majority of their other movements have not really trained the long head of the tricep. So when they finally do train it, it's probably going to get sore faster and exhibit. It's just not as neurologically or mechanically efficient
Mm.
because it gets a lot less volume of work in the majority of their training. For instance, take presses, right?
Yeah.
Like presses, you're going to work the medial and the lateral head as elbow extensors in those presses. But the long head is serving more like the hamstrings in a squat, where it's more kind of just maintaining, a certain length tension relationship to
Sure.
stabilize the joint.
Sure.
Um, so when you look at like, well, okay, what's been causing more soreness and things like that, you have to look at like, well, are we actually measuring these things equal, like in terms of how much volume they're getting? Because
Sure.
technique is a huge part of that, the overlapping exercises. And that, with the two joint muscles, that's a huge thing that people miss. And the other thing is the two joint muscles, because you do have two joints, are more prone to being loaded with a stretch. Like how much can you hyperextend the elbow to stretch the biceps and the brachialis and brachiomedialis? Not that much, right? But you can extend the bicep and the shoulder simultaneously to put a lot more stretch on the biceps than you can the brachialis and brachioradialis, right?
Yeah.
Or the coracobrachialis or so those two joint muscles are more subject to that stretch, which to me, in my experience, I think is actually a very important aspect of training them. I mean, when we think about, our natural movements, our full gait sprints and stuff like that, it's like, well, that's kind of what they're there for, is to actually bring in some of that more elastic tension and the force in those two joint movements.
Yeah.
The end of a sprint in either direction, the thing that's going to have like the most kind of passive tension and elastic energy built into it is always going to be those two joint muscles,
Sure.
right? Because they're able to be stretched around two joints. So I just want to make sure I'm answering your question like appropriately. Is like, so are you saying that you're averse to these movements because it seems more mechanically traumatizing in that lengthened position, or
No, I just think it's misunderstood and kind of misapplied. So
Mhm.
personally, if somebody has difficulty connecting with their triceps, feeling their triceps contract well, or even if they have like some sort of asymmetrical development from head to head, I would probably prefer them perform for the long head exercises in that shortened position to actually get a better mind muscle connection. When it comes to a development standpoint, I really don't have a belief which one's going to be better than the other. I think they're equally important, but I think just that general fitness belief that okay, this is training the long head is just misunderstood. And
Well,
even going back to like what you were saying about the medial and lateral head still being fully lengthened in its flex position, as you're performing the concentric, let's just say at the mid range, these heads are able to produce more force than the long head because the long head is still lengthened. Would you say they're contributing to the elbow extension to a greater degree?
okay, so a couple things that we have to consider here, right? So when we look at how much a muscle strength is going to change over the course of its length,
Sure.
it's not just the distance that it covers here. This is where like muscle pennation, muscle architecture really comes into play, because basically muscle architecture kind of functions like gears, but for range of motion rather than for speed. So for instance, the triceps, when you look at this, like you see a Rolly Winkler freaking tricep, and the fibers are just like all like that, right? And you know when we're looking at pennation angles and stuff, which by the way, for anybody watching this, you can't actually see the pennation angles. I'm just trying to illustrate the concept there, right? But so when you look at these muscle bellies that have these like hard pennation angles, what you'll notice is that as they stretch, those angles become more in line with the tissue, meaning that the sarcomeres are gaining mechanical advantage as the muscle lengthens. So that's the reason that we have quads and not uns, right? Because it's like, why which just crosses the knee joint, just the knee extension thing. Why do we need four of them? Technically, there's five, right?
Sure.
It's like, why do I need all this mess of shit on the front of my leg instead of just one big thing that just pulls directly in line? Um, and so that whole like change in architecture basically serves as a energy conservation through ranges of motion by saying like, well, this is more mechanically efficient here, this is more mechanically efficient here,
Sure.
whatever. Because when you look at basically, when we look at all this stuff, we look at the nervous system, we look at our biomechanics and everything, when we come down to like evolutionary biology and we look at this stuff, we can say like, well, if we were to think of how the hell would we have gotten to where we are now, it always comes down to, in some way, shape, or form, it had to have been better for survival. And the
Yeah.
main driver for that is conservation of energy. More than any other sort of adaptation, conservation of energy. So when you look at like, okay, why the nervous system changes the way that it recruits as we lose them, as we learn a movement pattern, right? It becomes more efficient, right?
Sure.
It doesn't know that you want to squat 400 pounds or bench 315. Like it
Yeah.
doesn't know, it doesn't care. It just is like, hey, we did a few reps, and the ones that we did a little bit more like this and not like this, they cost less, and that's the learning process, right? And we're able to learn from that biochemical stuff translating up into actual stuff that we can store in our brain. So so okay, everything's lengthened here, right? As we're coming here, you could say like, well, technically, the medial and the lateral heads, per their length relationship, are shortening faster than the long head of the tricep.
Sure.
Okay, because the long head of the tricep would have to shorten all the way down here.
Yep.
Okay, so when we say, is this more of X? So technically, when we look at a strength curve in a pennated muscle, which the triceps are all pennated to varying degrees, right? When we look at pennated muscle, that little curve that you always see in the textbooks for like the strength curve of a muscle, you can just fucking like grab that and throw it away, because
Yeah.
that is for there's two sources that comes from. One is they do it on a fusiform muscles where all the fibers run in line, right?
Sure.
And the other ones that they've done is they've actually measured like the single sarcomeres, which obviously just pulls in a straight line.
Sure.
There's not like, you have to actually look at force data, because you can't cut out a single sarcomere and then somehow make it do this in a
For sure.
in a little tension meter, right?
Sure. Sure.
So we have to take account the physics of what's going on, because the angle of direction of those is changing, right? And so with pennation, we get a change in mechanics. The other thing, just, pennation allows us to actually accumulate more contractile tissue in the same spot without becoming as inefficient in certain positions. Because the other thing is, as muscles get thicker, their angle of pull also changes. Like the fibers that are up here versus the ones that are parallel to my humerus are contracting at two different angles when I'm flexing my bicep, right? So in this case, you could say like, well, okay, as we go through that range of motion, they're being trained at different lengths.
Yeah.
Okay? Now, when we say, well, this is more, we have to quantify what we mean by more,
Sure.
right? Because we'll say this works more, like, but more needs to be quantified. Like, well, is this more tension? And if we're talking tension, are we talking tendon to tendon tension? Or are we talking like Z-line to Z-line sarcomere based tension? Because that's what actually translates into hypertrophy, not tendon to tendon tension per se.
Sure.
I mean, we could talk neuroendocrine stuff till we're like blue in the face, but that's that's like, yeah, we won't go there. But for the most part, most of our things that we're looking at from a training adaptation standpoint are going to be like, well, what's happening on the sarcomere to sarcomere based level, right?
Sure.
And so then we have to factor in the nervous system. Is the nervous system isn't going to say, well, just because this is this length and this is this length, this is getting more. What it's going to say is, who is most efficient at this moment in time? And every time I do a tricep extension, my body's taking inventory of who is costing more to produce this force, right? And so when we look at pennated muscles, the muscles that are starting to line up and have a more like efficient line of pull,
Sure.
they're going to be the ones that are starting to be favored in that case.
Yeah.
So it's not just, you can't look at muscle length and apply this strength curve as if it was one fucking sarcomere going from tendon to tendon, right? So when we're looking at stimulus, there's a different thing that happens when we're stretching the muscle. You're already on to that there's more mechanical trauma, okay? But there's also a different thing that happens when we shorten a muscle, especially pennated muscles. So when pennated muscles get shorter, the opposite happens. So they gain leverage as they lengthen, but they lose leverage as they shorten.
Sure.
Right? So their fibers become more horizontal in relationship to that, which means they have to expend more energy to create the same amount of force tendon to tendon. Right? So the muscles that are shortening faster are actually going to drop off in their strength and their efficiency sooner. So through this motion, the long head of the tricep actually is more mechanically favorable, because at this point, its sarcomeres are not like, they're not horizontal. They're still more efficiently lined up. So that is why what'll happen is the nervous system, provided you have the shoulder stability and this is all lined up, will use those more efficient fibers.
Yeah.
Right. So I would say, yes, you could, in a very general terms, say this is more long head because it is the mechanically favorable tissue. Okay. Now, does that mean that if you just do this, that you've sufficiently trained your long head of the triceps? That's not the message that I want people to take, because I think you need to train all of these tissues through their full range of motion, right? So you should train the long head in its short position. The nice thing is the other guys, they get full range of motion and everything that you do sometimes, right? So it's like, depending on what you're able to do, but that's technically usually not the case, right? Because if I come in here, if I'm doing a cable tricep extension, like if I'm doing this, like I never come up here, right? Because the cable will be pulling me this way. So I'm kind of missing this length and range on both, right? So if I come back here, I'm actually probably getting an area that even if I'm training a lot down here, I'm never really loading the lengthened position. I would need a resistance that's pulling me here. So when we do a lengthened cable, it's a cable that's pulling like kind of down, right? Like basically, crossing behind the back so that you actually get something here. Now, the more that you load this position, well, what happens if we start coming out here, right? Well, if it's a dumbbell it becomes a bicep and anterior delt exercise.
Sure,
So it's
sure.
like, well, if I really want to tax this position with something that's pulling down right in that lengthened position, I'm only going to get a half rep. Well, then that means this is where supersets and varying exercises and partial reps and all these things can be really valuable if you know how to use
Yeah,
them right.
yeah, yeah,
Um, I'm kind of rambling on here, so feel free to cut in and interrupt me
yeah.
wherever you want to. But so the answer is, I would say if we had to we had to put a black and white on it, then yeah, this is going to be more long head, because from both the mechanical perspective and a neurological perspective, I'm going to favor that tissue, provided I'm actually lined up appropriately. If I'm lined up like a jackass, then it doesn't matter, because
Sure.
the only way to like keep that position is to limit the contraction of the long head of the tricep,
Yeah,
right? Or provide excessive tension with antagonist stuff that's fighting this position the whole time. And you will see that. And that's where you have people that are like, you see all these influencers, or, these, some of these quote unquote, we'll call them educators for the sake of that's what they call themselves, but they'll come up with these positions that they're difficult to do, right?
yeah,
And people will just be like popping their eyes and veins out of their head doing like no load, but it's like, oh, it's so difficult, isn't it? You don't need any weight to train. And it's like,
yeah.
all you're doing is teaching your body to fight itself. I mean,
Sure.
you're essentially fighting your body, trying to limit tension in those tissues, and you don't gain any muscle that way. All you do is develop really bad movement patterns and joint stability.
Based on a lot of what you just said, a couple questions are trickling down now. I think you made a great point in regards to the strength curve that you generally see. Just kind of throw it out the window because there's so many other factors at play throughout the
I
range
mean,
of motion.
the
And
principle is there. You just have to take the architecture physics into
sure,
it as well,
I
right?
think that's super important. Going back to just how like some of the issues I have with the general bodybuilding fitness community, I think you were talking about like 2008 to 2012. There's a lot of forward thinking, and now everyone's just kind of regurgitating information. Um, you spoke about the line of pull and like where the tension is actually coming from and how that's in line depending on what exercise you're doing. I personally believe you can set up certain exercises. We're going to stick with the arms for now, to actually target like the lateral head of the tricep while you're doing a tricep extension exercise. And some people are like, if you're doing elbow extension, you can't, you can't, you know, favor one head over the other. And I don't really think that's true. I would be curious to kind of get your input in regards to exercises you might do to target the lateral head of the tricep, right? Because I don't think anything's created equal. Like I did the pull-up video that you mentioned where all vertical pulls clearly aren't created equal. Obviously, all elbow extension isn't created equal, but people like to put out this black and white, oversimplified information, I guess, just to make it more basic for people, but it's also falsified, right? So,
Yeah,
are you familiar with Jim Cordova, old
I am
school
not.
bodybuilder, natural bodybuilder? Anyway, he used to do tricep extensions with like an internally rotated humerus kind of coming across the body, kind of mimicking like the opposite of a hammer curl. So instead of doing like a hammer curl like here, he'd be
Yep.
doing rope extensions there.
Mm-hmm.
And before I even understood architecture of the muscle or kinesiology, like you can just kind of feel it a little more. And a lot of people would say it's not making a difference. You're just performing elbow extension. But what are your thoughts there?
Yeah. Okay. Well, let's go.
And I also think you can provide the explanation as to why it might be favoring a certain head much better than I can. So this is an opportunity for me to learn why I'm actually feeling it in that head more so than a different variation.
Yeah. So if we reverse engineer the thought process that we were talking about for the long head, knowing that it has to be lined up in a position where it's not going to be exhibiting other forces on the shoulder to be able to maximally contribute to the movement. So in this position, it's essentially we're putting the body in a position where producing tension in the long head of the triceps is a poor solution if I'm mentally also trying to maintain this position, because it would want to pull the arm back, right? So my intent of holding the arm here is going to inhibit like more tension in the long head of the tricep. Okay, so that means that the other guys are going to pick up work, right? So our medial and lateral heads are going to, do more of that work. Okay, and that context of like what's working more is very dependent. Like if in that instance, it's really easy to show how the long head of the tricep isn't coming into play because it's
Sure.
not a good mechanical solution. Now, when we look at the medial versus the long head, which basically have equal opportunity as elbow extensors from a biomechanics perspective, because it's like, well, they have the same role, like regardless of where the shoulder is, they're just extending it, right? But where one is going to be utilized more than the other comes down to that muscle architecture thing, is that the one that has the more favorable mechanical solution will get used more. And in order to separate that out, we're looking at where the resistance is greatest. So this is where we're training at multiple resistance profiles, like with the prime equipment, or adjusting your body position so that the moment arm is greater in a specific spot that you want. That's where we can train muscles that have essentially the same biomechanical function at a joint, but have different architectures, because where the resistance is greatest to overcome, if that matches where the tissue that I'm trying to train has the best mechanical advantage, that tissue will blunt the majority of volume of work, because you're not working the same amount at every degree of range of motion in exercises. Like it's
Sure.
very uneven in terms of our internal mechanics, the resistance profile we're overcoming, all the levers and stuff that are going on. So if we have an exercise where the resistance being applied to the tissue, including my internal mechanics, is very similar to that of the tissue that I'm trying to target, it's the best solution from a neurological standpoint and a mechanical standpoint, right? And so as I do that movement, my body's going to get better and better at using that tissue. That's why that we can get more efficient at relative simple movements. So if you take a beginner that's never done a preacher curl before, okay, right, and they do a preacher curl, they get stronger fast, right, when they're a beginner,
Sure.
because they're still getting better neurologically at doing that, right? And they're able to do more reps and be less sore and all sorts of stuff right there at the beginning. Part of that is being able to recruit more motor units. But a bigger part of that is being able to recruit the right motor units at
Mm.
the right time in the range of motion.
Sure.
Because if I use a tissue that isn't as efficient, I waste more energy, right? And I technically create more internal tension in relationship to the force I'm able to produce,
Yeah.
right? So I don't move as much load given the amount of energy output. And so my body is constantly adapting that. So can you bias just the medial head over the lateral head, or vice versa? You could through a resistance profile,
Yeah.
but not so much by changing like where this is, right? But pretty much the thing that your arm position is going to really impact is what's working, long head or not, right? Whether it's how much of a part of the puzzle it is. Okay. And then in the other heads, it's going to be like, well, okay, if I wanted them to work more, I could technically find a position that, doesn't use the other things, and is most efficient from a resistance profile with what this tissue does. So, but let's follow up that context with, when does this matter? And is it actually a good idea to try and do that sometimes? So the first thing is does it matter? And the answer is, well, in submaximal work, it definitely does. But as I start to fatigue, guess what? I got to use everything that can contribute. So when we start getting closer to failure, or we're working at higher loads, or whatever, or combination of those two things, or I'm extending sets with drop sets and whatever, I'm like all of these intensifying techniques I'm doing, uh, the more I get close to that failure in any category, the more it becomes less of a factor, because it's like at that point in time, it doesn't matter who's the better mechanical solution, because it's all hands on deck,
Yeah.
right?
Yeah.
Because it's like, all right, well, even if you were the best guy for reps 1 and 2, by the
Sure.
time we get to 3 or 4, everybody that does elbow extension is coming along, right?
Sure.
And so, excuse me. So when we get into the training side of things, and we're thinking about like, okay, how should this affect the decision I'm making in terms of what exercises and stuff is, I don't like exercises or the whole thought process of trying to disadvantage any tissue to bring up the others, because I think all it does is just reduces what you're able to accomplish.
But
I think that what you try and do is say, like, look, everything is able to contribute contribute to the movement in a functional way, but I've chosen a resistance and a rep range and like whatever intense or whatever to try and bias what I want to the most,
mm,
right? And if I've chosen the right resistance profile over time, what will happen is I'm getting a little bit more volume in that tissue, and I will have nice balance to the three heads of my triceps and whatever, right? You want to get really complex, you have to look into like, well, okay, if I'm trying to bring up my long head versus my other heads, like one, I don't like, for instance, I don't think there's ever a reason to do a tricep extension where the long head can't be part of the equation. The only thing that you will get is less stimulus and move less load, right? And you'll have a less stable shoulder joint, right? So it's like, what is the advantage? Because it's not that having the long head in there means that I can't train the medial head or the lateral head. I just
sure.
have to choose a proper resistance profile, use enough load, and train it to the appropriate degree of failure, and then it's a win-win for all of those guys, right? And my shoulders will be happier because I'm training all of my elbow extension in positions where my shoulder actually has better stability,
Sure.
right?
Cool, man.
So
It's a great answer. Great perspective there. Um, Another thing that came from the things you were saying beforehand, you were talking about so you're basically saying your body's going to recruit what's most efficient,
mhm.
right? To spare energy. When you perform some exercises like, let's call it a lying hamstring curl,
Mhm.
um, are you focused on extending your hips forward, shortening your glutes, and shortening your hamstrings while performing the lying hamstring curl, or you're just focused on knee flexion? And
So
what's your thought process there and kind of why?
So when we look at the long leg curl, right, and we're just trying to decide, is hip extending further to shorten the hamstring a good idea, right? One would be, well, the first thing that you'd have to determine is, okay, does that actually allow me to get a shorter hamstring, or do I actually just lose knee flexion? Right? I lose range of motion at the actual thing that I'm moving, right?
Yeah,
And in that case, like right there, we could just like, well, if the only thing I'm gaining by hip extension is a smaller range of motion in the exercise I'm doing, it's probably not a better decision, right? So there's one aspect. Okay. The other aspect is going to be, all right, well, the hamstrings pull on the pelvis, right? To be able to pull on the tibia, right? So if I make it harder to manage that pelvic position, then the hamstrings aren't going to be able to pull as much, which means I'm going to have to rely more on the other knee flexors, which is the gastroc mainly in this case,
sure.
right? So by hip extending, okay, I've pre-shortened that muscle, and
Yeah,
then what I've done is I've created like a less stable pelvis likely. I've I'm going to also pre-stretch the rec fem, which is the antagonist and whatnot. So what you'll get a lot of times, what we call these is like sensation-based exercises,
yeah,
where if you destabilize a joint, the sensation around that joint or in some of those tissues goes up, which can give people the illusion that they're working it harder,
mm,
when in reality, all they're doing is putting their body in a place where essentially the neural firing has to be more frequent because you're constantly taking inventory of those positions and manage it. It's harder to manage that, right?
sure.
So think of it this way: like if you come to a mid-range bicep position and you just kind of give yourself like just a hard squeeze, right?
Yeah,
Like you can feel tension in there, but
yeah,
it's not the same sensation that if you were to crank your arm
yeah,
like
yeah,
back as far as you could and do this, right? And you get like it's like crampy,
yeah, yeah.
right? And almost painful, right? And that is not a feeling of tension. That is not a feeling of a quality contraction. And a lot of people associate these kind of like extreme joint ranges that where their stability loss is like, oh wow, I feel that more. And in reality, we don't feel tension that well. We
Mm,
don't. Like if you've been training a long time, you probably have that instinct to be able to tell tension, right? But a lot of people don't. And so just any sensation, more of it is associated with better. And that's not the case. So when we look at that whole, like, well, we're hip extending, is a lot of people will get a greater sensation
Yeah.
because all of a sudden now there's a harder stability at the pelvis, right?
Yeah.
And your body's in a state where you're consciously trying to contract your hamstrings, but your unconscious nervous system knows that's a shitty solution to the job, right? And so you're essentially, you're essentially fighting conscious and unconsciously how to manage that joint, right? Like internally, your body's like, God, this guy's an idiot. What the fuck is he trying to do here, right? But you're like, oh yeah, feel that, it hurts, squeeze it, yeah, burn. So when we extend at the hip, we lose the ability to resist the hamstring tension as much, and we lose the ability to stabilize that pelvis as much because we're disadvantaging the tissues that would be opposing the hamstring tension. Okay. The other thing is if we pre-shorten the hamstrings at the hip, right, they're now shorter. Okay. So even though, that little resistance profile thing or that strength profile thing that's just like this, it's not completely accurate. The curve gets shifted massively in different directions depending on the tissues. All tissues still do get weaker as they shorten, but just to varying degrees. So if we pre-shorten that, but we leave the other knee flexors at the same length, like the gastroc, all I've done is I've made the gastroc a better mechanical solution in relationship to the hamstring. So if anything, this is going to make it more calf and less hamstring, right? Because the hamstring is not as good of a solution, right? So if you, yeah, yeah. So if I wanted to make your leg curl as little hamstring as possible, that's exactly what I would do. Is I would make you go into full hip extension, propped up with less stability, right? And then I would have you perform it that way because you're going to have less ability to pull at the pelvis, on the hamstring's origin, and the muscle's going to have less of a mechanical advantage over the gastroc, and therefore it's going to be recruited less. Nervous system's not going to waste energy if it doesn't have to.